Hello guys, welcome back to Math Tutorials. Today I have a different type of video and the first in a series of different types of videos from what you guys are used to, where I'm going to be going over some basics of calculus. Um, the idea being that now that school is out, at least for me, it's summertime, so one, I have no homework to draw things from, and two, nobody really cares about doing, practice problems from calculus. But I figured maybe when next school year starts, people might want to be like, oh, I kind of forgot what this is. What is, a derivative? What is an integral? And then they might want to look back at some videos. And so basically what I'm thinking is all the videos I make over the summer will be sort of, recap type videos aiming for an audience that is just back in a calculus class after having taken a year off. Not a year, a few months. So with that being said, today we're going to do the derivative basics. So things I want to cover today are the power rule, trig derivatives, and the chain rule. Okay, so first thing, the power rule. Right. Well, let's say what is a derivative, right? Um, let's see. What is a derivative? A derivative, you can think of it as the change or the slope, I think are mainly the ways I think about it. So if you have, let's say, the function, y equals 2x, right? You have something like this, and you're like that, right? You want to see how much it's changing by at each change in x, right? So if I go over some distance x, how much is it changing by, right? Some distance x, how much is it changing by, right? You could also think of this, um, well, this works when you have like 1 point here and 1 point here, right? And then a further distance, 1 point here, 1 point here. And the kind of idea is that you kind of shrink the distance between these 2 points until eventually you're kind of just looking at the change, at the slope of 1 point, right? If you had like this, except you went over barely any and like went up a little, barely any, right? The amount that you go over is decreasing each time. And that's the whole like limit definition of a derivative, which we covered, which I don't really feel like covering in these videos because that's like the first few weeks of a calculus class and I don't really care about it. So again, another way to think about this is the slope at any point, right? Because obviously doing this, you know, point A, point B, right, rise over run, that's just going to be the slope, right? Um, so you can think about it as, like I said, change or slope. So now if we had this one, right, what would be the derivative at, let's say, this point, right? Well, pretty clearly, the slope is going to be the same everywhere, right? Which means that right there, the slope, we know y equals mx plus b. This m right here is the slope. So if we're trying to fit this into this, clearly b is 0 and m is 2. So the slope is 2, which means that the derivative of y at any point is 2, right? At any point, because crucially, derivatives can change at different points, right? If I had something like this, right? Something like woo, something like that. Clearly, the slope here, because the slope of a tangent line, so the slope here is not the same as the slope here, right? Not the same as the slope here, okay, here. And this one might not even be defined. I mean, what even is the slope at this point, right? Who knows? But clearly those are all different. So it can change throughout a function. It just so happens that in this most simple example, it doesn't. So the derivative or the slope of the line at any point is 2. So pretty simple there. Now, the most basic thing, I would say the most crucial, like fundamental skill is knowing how to use the power rule. And this comes up when you have something like a polynomial. Let's say you have, y equals x to the fourth, or actually, no, let's keep it simple. Y equals x squared, right? We know what this looks like. Looks like this, right? So how do you find, okay, well, this actually touches here, right? So how do you find the slope? Because obviously the slope is going to get, oh, by the way, derivatives can be positive or negative, right? So positive, it's going up to the right. Negative, it's going down to the right. So clearly it's going to be very negative here, right? Because the slope is like that, and it's going to be less negative. But all the way at the left, it's going to be like negative infinity. It's going to go to infinity, basically. And then it's going to go, looks like, to 0. right? Because right here the slope is 0, and then it looks like it's going to go up really high again. So what you actually do is you well, you take this exponent and make it into a coefficient, right? So then you have 2x squared, and then you take this and subtract 1, which gives you 2x to the 1, or just 2x. All right. And this works for any kind of thing of this form of x to a power. But it has to be just by itself. It can't be x to the power, sine, you know, x to the fourth. You can't just say, oh, well, that's, sine, 4x to the third, something like that. You can't do that. It has to kind of be by itself, which is why it works so well with polynomials, which are often the form, x to the 4 plus 3x to the third minus 1 x to the second, plus x plus 1, something like that. It works really well for those. Um, and so also we can notice that this fits our pattern that we wanted. If x is really negative, it's going to be 2 times a really negative number, which is going to be an even more negative number. 2 times 0 is 0, and then 2 times a positive number is going to be a positive number. So this even works something like I said, uh, some crazy polynomial like this. Not that this polynomial is actually all that crazy, but um, uh, actually, yeah, plus, sure. So for something like this, you can actually go term by term. And you can always do a derivative um, term by term like this. So if you have like derivative of something here plus something here, and you want to find the derivative of this whole thing, you can do the derivative of the first kind of thing plus the derivative of the second part of the function. Um, and this works only with addition. You can't do this with multiplication or with division. If I change this to multiplication, then it doesn't work. If I change this to um, division, it doesn't work. If I change to subtraction, it does work. Um, but yeah, addition and subtraction is kind of where you can use that. But that actually helps us in something like this polynomial because that means you can go term by term. So let's use the power rule, right? Make this a coefficient and then decrease it by 1. Make that a coefficient. Well, technically you're multiplying by it as a coefficient. So here where we already have a coefficient, it would be 3 times 7. So 21x squared minus 16x to the 1 plus 19. And then here we can kind of think of this as being like x to the 0 and then multiplying by 0. So really this whole term cancels out. Um, and so really what happens is anytime you have just a constant, the derivative is 0, which makes sense because if you think about the graph of a line, let's say y equals 5, it's like this. Okay, well, what's the slope at any point? Oh, right here it's 0, right here it's 0, right here it's 0, and it's 0 everywhere. And that also relates to the definition of the derivative as a change, right? Because you can see it's not changing at all. Right here it's changing by, 2 times x, change in x, but here it's not changing at all. Another way to use the power rule is with exponents that aren't integers. So even if you have like x to the, you know, 3/5, you do the same thing. Derivative, you multiply by this out front, and then you subtract 1. So that would be what? Negative 2/5. And then if I want to take the derivative of this, right, what I would do is multiply by that, so that'd be negative 6 over 25 x, and then subtract 1 from this. So negative 7 over 5, right? And you subtract 1. So if you're negative, you should keep getting more and more negative, basically. And this is the second derivative of this, right? And this is the first derivative of this. So that's the power rule. Now the trig, I'm just going to do the basic trig, just sine, cosine, negative cosine. So the way you want to think about the trig is kind of in a cycle, where you have sine, cosine, negative sine, negative cosine. So the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, and negative cosine is sine. That's kind of how you want to think about it. And it's really that simple. Of course, there's always like arc sine, tangent, whatever. Um, but that's more complicated. Tangent, we're going to learn a thing. I think maybe next video I'll do it. Um, the product and quotient rules, because if you think about um, tangent as sine over cosine, well, we know the derivative of these individually, so if we can find some way to combine them with the division operation, then we can find the derivative of tangent, which we're going to learn how to do probably next week, if I remember. But that's basically trig for right now. Now the chain rule is a way of doing a function inside of a function. So if you imagine something, kind of abstract like f of g of x, right? What are we saying here? We're saying we have a function f, right? And the input of f is another function, right? So let's say f is, x squared. Actually, let's say x is sine x, and g of x is x squared. So now f of g of x, well, we have sine x is f of x, but we're replacing x with g of x. So we're replacing x, right? We're getting rid of that, and we're going to substitute in g of x, right? This. So we're actually going to do sine x squared, right? And if you just see something like sine x squared, you might not think about that as a function inside of a function, but thinking about it that way really is useful when trying to find the derivative because of the chain rule. And so what the chain rule says is that um, if you have f of g of x, and you want to find the derivative of this, by the way, the derivative is d over dx. You can that's like, I don't know, a way to show that you're trying to find the derivative of this. That is equal to the derivative of g of x. So the first derivative of g of x times the derivative of f of g of x. Now, crucially, this is not the derivative of f of the derivative of g of x. G of x remains the same inside of f, except it's just that the derivative of g kind of pops out. So if we use our example of earlier, sine x squared, if we want to find the derivative of this, first we need to see what's g of x and what's f of x. So f of x we saw earlier is sine x, and g of x is x squared. So we want the derivative of x squared, which is going to be 2x, like we saw with the power rule from earlier. And then what is the derivative of f? Well, sine goes to cosine, so derivative of sine of f is cosine x. But remember, we don't want x, we want to replace x with regular g of x, so x squared. So a crucial thing to notice is that the thing that's kind of like the inner function, that g of x, stays the same, right? From here to here, g of x is in both. F of x changes, right? And then this kind of new thing pops out, but the inner function stays the same in both. Um, and I think that is pretty much it for the basics of a derivative. I know I didn't go over like the kind of theory and how they get there, how they, do the limit definition and all that, but I think, it's honestly, I don't think it's that important. I think if you know how to use it, that's more important than knowing like the foundations of, philosophically why we need the derivative or whatever. Um, so yeah, I think this covers the basics, and hopefully, this kind of jogged your memory if you're looking back on this in a few months. So yeah, thank you. Next time we're going to, if I remember, next time we are going to cover product rule, quotient rule, and anything else that I remember and feel like should go in that video. Okay, so thank you for watching, and I will see you next week. Goodbye.